Hi guys. So first off, I am so sorry that I forgot to mention yesterday that I would not be here. I sort of forgot as of yesterday that I would not be here this hour today. Um, but don't panic. I know that this is tough stuff. We're going to keep plugging away and practicing at it today, and I promise tomorrow we will have all the time you need to go over any questions that you might have. Okay? So first off, I did post answer keys to last night's assignment on Google Classroom. And so today I'd like you to use some time to log into Google Classroom and take a look at that, see how you did, and like I said, we will have plenty of time for questions tomorrow. One of the things I did do was for the book work, I created an answer key for at least the proof part of every question, because I thought that might be a little easier to follow than the book. It is still a little bit difficult to just look at a written out proof and to be able to follow it as opposed to having someone explain it to you. So do the best you can with the answer key. But if you're still having trouble, just mark down any questions that you want to go over and we'll make sure to cover them tomorrow. There is one more little piece we need to add into what we've been doing so far. And we've actually already talked about this, but we just need to formalize it a little bit. And that's this concept of singularities. Singularities are places where a function is undefined. And I don't have an actual place in your notes for you to write this down, but I would recommend that you flip open to yesterday's notes where we were doing all the proofs, and you can ask the sub politely to pause the video if you need a minute to get settled there. But if you want to flip open to yesterday's notes and just jot this down, and then the examples we're going to do today, we're actually just going to pull from the homework assignment you did last night. Okay? So if I'm thinking about the unit circle and I'm thinking about where things are undefined, sine and cosine don't cause us any trouble anywhere. Okay, sine and cosine are never undefined. The first one we've run into that is undefined is the tangent, okay? And tangent is undefined at the top here and at the bottom. So really what we're marking on this picture is where these different trig functions are going to be undefined, okay? So tangent is undefined top and bottom. The reason for that, and I think I'll put this down at the bottom. Some room here. The reason that that happens is because tangent, we know, is really sine over cosine. And these locations here at the top and the bottom, this is where cosine is equal to 0. Okay, if you think about it, it makes sense that right there my x value is equal to 0. Okay, so cosine is equal to 0 top and bottom. And therefore the tangent is undefined because we can't let the bottom of the fraction be 0. Okay. We know another trig function that has cosine on the bottom, and that's the secant. Okay, secant, I'll skip a line here, is equal to 1 over the cosine. So on that one, the cosine is also on the bottom, and so that would also be undefined in these locations. Okay. And so what we would call that kind of collectively here, this is pi over 2, this is 3 pi over 2, and if I kept going around the circle, this would be 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. So really what we're looking at here are odd multiples of pi over 2. That's how I would describe those things. Odd multiples of pi over 2. Okay, so next up is cotangent. And cotangent has sine on the bottom because it's the reciprocal of this. And we're going to find that sine is equal to 0 at the right and the left. Okay, or like 0, pi, 2 pi, and so on. So these are the places where sine is equal to 0. Okay, and because cotangent is equal to cosine over sine, and sine's on the bottom there, then I would say cotangent is undefined here and here. And then my other one that has sine on the bottom is the cosecant. So that's 1 over the sine. And so these are also undefined here. So it's going to be important that you know these four things, okay? That you know where these four things are undefined and which items are undefined in which location. I really would not stress about memorizing, okay? I would focus more on knowing how these things are set up and being able to understand that, okay, so cosine's on the bottom here, and that means wherever cosine is equal to 0, that's where I'm undefined, okay? Or wherever sine is equal to 0, that's where these things are undefined. These, by the way, like I said, was 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. My video can't keep up with me, okay? But really what those are the multiples of pi. That's what we call these. Just to finish that out there. So like I was saying, you are responsible for knowing this stuff. I would not try to memorize. I would try to make sure you understand why these two things are undefined in these locations and why these two things are undefined in these locations. So what's going to end up happening is you're going to be looking at something and it might have a cosecant in it. And you're going to have to be able to identify where that's undefined. And the thought process I hope you would go through is, okay, well, cosecant is 1 over sine. Sine's on the bottom. So we need to think about where sine is equal to 0. Sine is your y coordinate. So this is where our y value would be equal to 0. And so therefore it must be multiples of pi. Okay, that's kind of the process that you're going to be going through. So you will want to make sure you have this written down someplace for you to refer to and for you to practice studying. Again, you are welcome to ask politely for the sub to pause the video right here before I jump into some examples of what I mean by singularities. Okay. I'm looking at your homework from last night, and like I said, this answer key is is posted on Google Classroom, so don't feel like you have to get it all written down right this minute, okay? But I'm going to look at that first example here, and actually I'll try to squeeze it in maybe at the bottom here. So as an example, that first one from your homework said secant theta times sine theta, okay? And so when I ask you for singularities, what I'm looking for is where is this expression not going to work for me? Where is this undefined? Well, I know there's no problem with sine. I do know secant has some issues, right? Secant is undefined at odd multiples of pi over 2. So when I'm asked to define my singularities, I would just say exactly that. My singularities happen at odd multiples of pi over 2. Okay? Because what we're really saying is that this expression, and we actually found on the homework that this came out to equal tan theta, and we're claiming that this equivalency is always true, right? We're saying that these two things are equal to this all the time, except it won't work at these odd multiples of pi over 2 because we're going to run into undefined expressions. Okay, so that's all I mean when I say define your singularities. Okay, is tell me where is this thing undefined. And as long as you know this, you'll be fine. Now, I am going to throw one more thing at you. I know you're happy about that. Let's grab the next example. Let's actually do number 3 from that same worksheet. So on number 3, and again, if you're looking at your homework packet, you'll see this. We had tangent squared of theta minus secant squared of theta. Okay, so you can't see that, sorry, number 3. Okay, tangent squared theta minus secant squared theta. Tangent and secant both have cosine on the bottom. So I would say that my singularities, because cosine's on the bottom, I'm looking for where x is equal to 0. That would be top and bottom, right, on your circle. So that, again, is odd multiples of pi over 2. However, with this one, as we were doing all of our math and all of our steps, we somehow got away from, like if you look through this whole process, we had cosine on the bottom all the way up until the end, and then because we ended up letting these two things cancel out, we no longer had a cosine on the bottom. We ended up at just -1, Okay, this thing we found to be equal to -1. And again, if you need more time with that answer key, you'll be able to look at it in just a minute. -1 is not undefined anywhere, okay? There are no singularities for -1. Let me just jot this down. There are no singularities with my answer, okay? Which means this singularity vanished somewhere along the way. We don't want to say that it's not a singularity, okay? We don't want to say that somehow we don't have any singularities because we know this was an issue back here at the beginning. What we're going to do is we're going to say this is a removable singularity, okay? So a removable singularity is one where at the beginning of the work that you're doing, it exists, but then somewhere along the way, mathematically, it drops out of there. It is still a singularity. It's still a place where your expression is undefined. But you have to be careful with your answer because even though this looks like there should never be any problems with this equaling -1, we would still have undefined locations. Okay? I'm trying to skim for maybe one that looks a little bit different. All of those ones look pretty much the same. Let's take a look at numbers. So this is actually from the bookwork. And again, you could just jot this down as an example or just follow along if you want. This is bookwork number 5. Asked you to work with this expression. 1 plus cotangent squared of x equals cosecant squared of x. So I'm kind of looking over here first, right? And I'm looking at cotangent. Cotangent has sign on the bottom. That would be your y values. So y is equal to 0 at multiples of pi. So before I even start this problem, if I was being asked about singularities, the first thing I would do is say, hey, I have singularities at all multiples of pi. Because that's where cotangent is undefined, is at multiples of pi. When I ended this problem, I ended at cosecant, which is also undefined at multiples of pi. So this singularity did not go anywhere. This singularity did not change one bit, okay? And so this I would just leave it alone. I would say, hey, that's a singularity, my multiples of pi, and I would move on with my life, okay? Trying to look for maybe another one here. Okay, I think all the other examples are going to be really similar to what we were just talking about. Oh, here's one. Looking at number 13 from your book work. Tangent squared x times cosine squared x equals 1 minus cosine squared x. And again, I'm going to show this all in the answer key, okay? But we were trying to prove that this statement was true. So before I start my problem, I'm going to say, hey, I have singularities because I have tangent, right? Tangent is undefined at odd multiples of pi over 2, okay? By the time I get to the end, what actually ended up happening on this one is this reduced down to equal just sine squared, okay? Let's see, I have that here. On this one, my cosine squared dropped out and I was left with just sine squared, and this side reduced down to sine squared. So if I look at sine squared here, there's no issue with sine squared. There's no singularities. My singularity vanished right here when I crossed out that cosine squared. So I would then go back to what I had already labeled as my singularity, and I would say, hey, that's a removable singularity, okay? I emphasize the way I would approach each problem where I identify the singularities and then identify whether or not they're removable because I don't like the format on your homework assignment. Your homework assignment is more proofs for you to practice. I know that overjoys you, but again, we'll have plenty of time tomorrow to practice if we need it. Oh, I can't find your homework assignment. To show you what I mean. Here it is. What I don't like, ignore that, is they ask you for the singularities and then they ask you for the removable singularities like they're two separate things, okay? What I would do is at the beginning, ask yourself where the singularities are. And then just think about it as when you're done, identify which ones were removable. Okay? So it's up to you whether you want to write them and then write out the removable ones, or whether you want to write them and then maybe just circle them and draw an arrow if they are removable. It's totally up to you. Okay? But it's not like it's two separate processes. It's finding the singularities and then deciding whether or not they're removable. Okay? And you can have all different combinations of these. You can have some where there's no singularities. You could have them where it has singularities at both locations and one of them removable, but one of them is not. Okay, so there's lots of different ways that you can do it, but the only places you're ever going to have singularities are at those 4 locations: top, bottom, left, right. Okay, practice that tonight, and I would be happy to help you with this tomorrow. We'll take all the time that you need to go over this. We'll go over yesterday's homework. We'll start back at the beginning of the lesson if you really want to, whatever I can do to help you. Okay, have a happy Halloween and use some time to get some work done, okay? I can't get out of my video.